Hello, everyone. I'm live again, and today we let me check this stuff. I'm trying to see and ensure that you guys can see me. Okay, I'm being seen, and I guess I'm being heard as well. I need to leave a message. Okay, live. Okay, I guess I still need to copy the link to the live stream for you guys. All right. I should paste this in our WhatsApp group. Yeah. All right, so the links to the live stream have been pasted on the WhatsApp group. Yeah, so I guess I can move on right now. All right, um, today we'll be talking about arguments, Argcs and Argvs. Argcs and Argvs are very important aspects of C programming. In fact, by the end of today, I believe that uh, we'll all start getting comfortable thinking about our projects because we have two major projects here in C programming. We have the printf project and we have the simple shell. You know, I've been greeting you all till today as hello everyone, and that's because you've not carried out your first project. From the instant you finish your printf project and your simple shell project, which is coming up really soon in a few days or weeks or so, you know, I think the Prince F has already started, but we are behind on our own schedule. And the instant you do those projects and you finish them with all the concepts that I've been trying to teach you, I believe that I can start calling you all tech bros. You know, your minds would be working. You would have implemented all the pseudo coding, data structures, algorithms that I've been teaching. You have understood how to think like a software engineer. So we are looking forward to having these projects. Yeah, I'm hoping that you will get there really fast. For now, we are going to be talking about a very important concept that you cannot do without as a software engineer. You know, you have to you have to understand how. First of all, you know, we had a conversation sometime. with a few students where they claimed they wanted to learn cybersecurity and all that. And I told them I was of the opinion that the only reason I'll be teaching anything more than software engineering, as in cybersecurity, you know, is that you are already a graduate of the software engineering training program. We are taking our time to teach all the concepts that you require to understand for you to build a complete, software. And it's very important. You cannot become a cybersecurity expert except you're a complete software engineer. Today, you start finding out that in the terminal we can build an entire console. You would build a console. Your simple shell project is coming up. Imagine a person who does not understand how to use the computer like a software engineer, and he's telling you he's learning cybersecurity. I wonder what he's going to do. Come on, we recently built, shell programs that run in the shell. They don't have user interfaces. We'll build it here on this training. You know, we use the computer completely from the terminal, and we clearly understand how all the commands work. We command prompt we give the command prompt commands, and it keeps doing what we want it to do. You know, all functionalities, like we don't need a graphical user interface for this. So imagine someone who does not even know what software engineering is, and he claims to be a cyber security expert. Come on, we could actually connect to remote shells from the command line and use the entire system and entire organization resources without having to use the user interface that you are comfortable with, you know. So I believe that all those people giving administrative knowledge, they just tell you how to hide your password and all those stuff. That's not what it is. We are trying to make you competent enough to work anywhere in the world. We are trying to make our learners competent enough to work anywhere in the world. That's the most important thing. So first of all, for our today's class, we are at arguments. Let's go to your documentation. Like I said, each time we come on these classes, I hope we are even behind. So I hope that you have already read all this stuff and you've looked at your documentation for that class. Anyways, I'll try as much as possible to make this very explanatory as possible because it's very important. This is how we pass arguments to the command line, you know, when building like a program on the command line. So this is the start point of how the computer understands the arguments that we are passing in C programming. And it's let me switch my screen. Yeah, it's very important. It's something we cannot do without. All right, so we are thinking about command line arguments, Argcs and Argvs. Now, before starting this project, you should know what an Argc is and what an Argv is. So an Argc is like an argument count. It tells how many commands that you've written, that you've given to the command line, to the command prompt. If you passed like a few, we usually pass commands to the command line, a lot of commands. We've done a whole lot. Each time you like pass a command, let's say mkdir and something else, let's say you want to make a directory called directory. This is two arguments that have been passed to the command line. One argument one and argument two. Okay, so argc is going to print two because it counts how many arguments that we've passed to the command line. Let me see. Okay, you guys are here. It counts how many arguments that we've passed to the command line. What am I streaming? Okay. Sorry, I was just trying to be sure that you guys are seeing my screen and not my face. It was really important to me. Where was I? Yeah. So this was where I was. I said Argc is the number of arguments that is passed to a command line. Argv, it, it contains like an array of all the commands that was passed to the command line. So while Argc prints the number of arguments, Argv will be printing out all the arguments. You know, it holds all the arguments that last time we did something like mkdir, and we said the name of the directory was directory. So Argv will be holding mkdir and directory. And it looks very simple, but it's a very important concept. In fact, it's one of the most important concepts that you need to understand to start building shell programs. You need to know what arguments you are passing to the command line. It's trust me, I might even say the most important, you know. Then let's go back to our question. You know, I've said what these things are, you know, and how the command line arguments are passed into the main. Okay, all right. This we can only explain this when we start tackling our assignments. You know, our assignments will just teach you this. Okay, so let's go further. They are saying by the end of this project, you should learn and be able to explain without the use of Google how to use arguments passed uh, to your program. You know, by the end of this class, you should understand fully how to use arguments passed to your program, how to manipulate uh, parameters that you pass to your command line, how to use them inside your work, inside your code, your to you know uh, manipulate them and use them to get the outputs that you want. So I'm going to do that. I'm going to help you do that with an example or two. Um, Two valid prototypes of the main, two valid prototypes of main and when to use them. Okay, when to use the Argcs, Argvs, and the main void. You would still use this. Your basic, the assignments would teach you how to use this. You just have to solve your assignment problems. And here they are saying how to use attributes unused or void. Okay, so attribute unused is like each time we pass it to the command line, each time we have like arguments that we are not going to use in our code. That's just so that the command line does not warn us, because the command line, I told you guys, C is very unforgiving. It will throw a warning, you know. And recently, the way we compile things, we tell the GCC to use like WERON, like to treat warnings as errors, you know. That's just so that we are very sure of what we are doing and we always get the right results. Anyways, we should go further. Um, the community rules. Okay, this one is just saying you should not copy. You should try as much as possible to understand everything that we are doing here. Here, remember, you should always have a README file that explains this thing so you can understand what you learned later in your code, in your project file that you are submitting. Very important to you to have that. It's very, very important. Here's this stuff. Okay, no global variables, no more than 5 functions per file. Okay, here they say that we are allowed to use printf and the built-in a to I function. This function converts strings to integers, you know. But well, I think I will build this again. I will build this. This is just to increase your to give you a foundation level knowledge of what programming feels like, you know. So I'm going to, instead of using the standard library one, we are going to build our own because of this class. I think I have a few time to spend with you guys. So all functions and prototypes like putchar, and putchar should be in the main.h file. All right. So that's for that. Your repository should be this, and your directory in your repository should be this for your GitHub when you want to submit. So really important. We are at question 1. So question 1 says write a program that prints its own name. Write a program that prints its own name. Usually the name of a program should actually be when you compile it, it should actually be the first argument you pass to it to run it, right? Because after like see here, after compiling this program that we wrote, we gave it a name, my name, and to run it we are saying dot slash my name, right? So this is the first argument we are passing to the command line. So we want a program that prints this argument. That, and how can we do that? We just need to know the Argv variable, you know, there, which is to say that we need to use this here to tell the computer, to tell the command line that the Argc might not be used, that it should not throw a warning. Argc is the count, how many arguments was passed to the command line, while Argv represent the argument themselves. All right. So since we are doing this, we would need a command line. Okay, so let me open my command line, this args. So let's make directory arg. Let's call this arg and cd arg. So this is where we'll be working. Clear ls, there's nothing here. And where do we start from? Where do we start from? The program said we should make a main.h file. I think that's where we should start. Let's start by defining the prototypes that we would need for this program. Vi main.h. Yeah, so remember I told you, we first of all, each time we do a main.h file, we want to know if it's defined or not in the program. Each time we call a main.h file in the program, we want to know if it's already defined. It is only if it is not defined that we want to define it. So file underscore main, and then we want to say if this is not defined, then we want to define it. File underscore main. Hope I'm not making any errors. And then we want to end if. Very important. I made a mistake there. End if. Wasn't doing this. So I sometimes my syntax, I see my syntax errors a little bit late, and this is just because I have so many other programming languages I write during the week. I'm coming back to C, bringing my minds back to C each time I come on Saturday to talk to you. And like I told you guys, when you learn programming the right way, you don't get stuck on one language. It's easy for you to you know it's easy for you to learn and diversify, and you get a new job and they are teaching you a new language. It's easy for you to just start writing it, and not like when they just teach you JavaScript and you'll be like you're a JavaScript programmer. That's wrong. That's why you need to understand the foundation, you need to understand the basics, you need to know C, because a lot of the other programming languages you'll be learning is just syntax modification from C. C will give you the codes of what programming is, how a programmer should be thinking logically, how algorithms, how data structures work. You know, the higher level programming languages, what they've been doing recently is that they try to reduce the stress that C comes with. C is stressful. We have to account for every single thing. But the new programming languages reduce the stress a little bit. They don't want us to account for every single data, every single space in memory and all that stuff. So we are fluent. We when you learn this thing the right way and you're doing a language that is easier, it's everything is just easy for you. You just need to learn the dynamics of every new language, and it's easy. Sometimes you like make some syntax errors, you get errors, and you can correct yourself. It reminds you, oh, when I was learning the dynamics of this new language, this is what they said is the peculiarity, or that is what they said is the peculiarity. So having that been said and done, we should all try to learn the right way, and that's what we are doing here in the WinMingle community. We want you guys to to have a solid foundation this stuff. So you are at the right place. So yes, we are to define what should we use. I think we're building our a to I, we're using a put char, and we'll be using the a to I function. We build an a to I function as well, like I said. So those, I guess those are the basic two that we need. So in essence, we'll need to do int uh, underscore put char. We've defined this a lot of times on this training. Char, and it used to take in a C, right? And int a to I underscore a to I. So this, I guess, this is the first time I'm building this for you guys. That's why I want to build it. I want you to understand. Let's use a pointer to S. Very important. So these are like the two prototypes for our function. If you don't understand what we just did, it means you've not been following up. You've not been doing functions. You've not done static libraries and all of that. So you should go back to it. Yeah. So the next thing that we should be doing is we should start tackling our questions. So the first one says write a program that prints the number of arguments that is passed into it. Requirement: print the argument excluding the program name. Print the number of arguments. Oh, yeah, excluding. I was wondering how would it print the argument and not print the program name. So excluding the program name, then print the number followed by a new line. Okay. So we should print a new line immediately after printing the argument. Right. So where's my command line? Yeah. So let's call this. What did he say we should call that? Oh, this is another question. Write that prints its own name. Okay. Write a program that prints its own name first of all, not number of arguments. This is zero. We're reading question one. So first, let's start from question zero. First, it says print the program name followed by a new line. If the executable name changes, the output should change to the new name. Okay. Do not remove the path. Do not remove the path from the program name. Oh, okay. So we should not remove dot slash from it. All right. Uh, this is doable. Very, very doable. It's easy. I guess it looks easy for me because what's the name of the file? It says what's my name.c. All right. I guess it looks easy for me because I'm the one teaching this stuff. What's my name.c. All right. Yeah. So that's that. First things first, we want to include. We will be printing out stuff to the screen. So we want to first things first include a stdio.h. Yeah. And then next thing we want to include our main file that we created. Always don't forget main.h. Yeah. And like I said, you guys should always have comments in between this stuff. But I'm jumping. I'm leaving this comment part to go do the function, to go build the function. Okay, so int main, this is what it is. So this is where the let me just do the structure, and then we go back. Remember, we were supposed to use we are supposed to specify the unused argument. So int arg is a number, you know, argc. It's argc is a number. So we have to now use the attributes, you know, unused attributes to make the computer know that we are sure we know what we are doing. It's we are not using it on purpose. Okay, so attributes unused, you know, attributes um used, attributes unused. All right, I need to put a comma there. Yeah, so that's what it is. Now we saying this to the computer is like we telling the computer that, oh, we know that the argc variable was not used. Okay, so don't throw a warning. This is our intention, right? So don't warn us. We don't want to hear you complain. So Argv, this is the one that we are using. So because we are using it, we don't need to come uh, complain too much. So let's um, make this able to hold a list of arguments. Okay, so Argcs and Argvs, this is the basic structure of the function. We read this in our question when it said that we should understand, at the end of the day, we should understand how to use this, as well as we should understand how to build the prototype. And I told you when we start our assignments, you would understand it. So yeah, that's the basic function prototype pattern that we are using for this stuff. So Argcs and Argvs, we might not use the Argc. We've told the computer we are sure it's not a mistake, so don't complain. So what did the program say that we should do? The program said that we should print, and they say we are free to use the printf. Okay, so the program said that we should just print the argument. So what do we do? Let's bring in the placeholder to a string. Okay, we are supposed to placeholder to a string. Yeah, that's how it's supposed to look. And then the program also said if we only print this stuff and we don't add a new line, we fucked up. So we need to add a new line before we close. Okay, so this way it prints the name of the string and then it prints like a new line before it skips to the next. Okay, all right. What are we printing? We are printing the argv variable, and that's basically all of it. We need to return, the main function must return something. I told you guys, so we need to have a return value. Let's just return 0, and that's that for our program. I guess this should run, shouldn't give us an error. What do we do? Okay, let's do gcc on it. Gcc what's my name, gcc what's my name dot c, and it should print an output into uh, dash o what's my name. Let's see, what's my name. Okay, hey, come on, bro. Oh, we got like an error. And where was that? That was in our zero dash. Oh, what's my name? The name is actually supposed to be zero dash what's my name, but that's another error, and it's fine. You should use the proper name when you're doing this stuff. Okay, so let's see if this compiles now. Hey, yeah, it doesn't show any error anymore, which is to say that we are correct this time around. And like I said, when we were teaching debugging, each time you see an error, patiently read the error message. I read this, it put this in red, and immediately I saw this, I saw that this was an error. You know, it tells us like C is unforgiving, but it points out where your error lies. Okay, so yeah, what do? We should run this stuff, and it says we should see the program name, right? So this stuff is what's my name, and yeah, voila, that's how it prints. It prints what's my name. And the question further said that if the executable name changes, that the program should also change the to the it should also print the new name. So what's my name? Let's say we all know that my name is Greenfield, right? So let's move what's my name to Greenfield, right? Yeah, so let's do this. Greenfield, let's run Greenfield, and you see it prints Greenfield as well. So that's that for that question. It's really simple. Like I said, it's just us printing the argument. So this is just to tell you that we've now been able to pass the argument to the cat. Let's cut it. Cat. Sorry, cat. What's my name? Dot c. Yeah, you can see that all we are doing is that we are printing the arguments on this function here is actually, you know, catching the arguments on the command line. Like we ran Greenfield on the command line, and we said here that the function The main file should print it out, and is actually printing it out, which is what we want. Okay, so we are on the right track. This is just us. This is you now. You learning this is you've already learned everything about Argcs and Argvs. The rest is logic, you know. The rest is your programming acumen, what you can use whatever you pass here to do. I've taught you guys a whole lot. I'm still going to teach a technical part of this stuff, just so that you know we that's why I want to build the A to I function, just so that your the cause of your programming acumen, how you think, increases. Um, let's go further. Let's go to question one because we don't have too much time on our side. Um, let me see if you guys are here. Yes, that's the see these guys. Okay, we are here. We are learning. Somebody says, "God have mercy on me. I am behind." Though. Yes, you are. Oh. You better go and work fast and work hard, work really smart, because you have a whole lot to learn. We've covered a whole lot in just like a few months. And like I said, we are teaching this stuff the right way. So there's a lot more that I still have to teach you. I want a scenario where by the time we are done with this program, each and every one on this training is competent, is good enough to work anywhere in the world. Like you can sit in a meeting with white guys programming and you don't flinch. You're not scared. You know what you are doing. You know. So we have a lot to learn. We will go further. This knowledge that we are sharing here in Nigeria like this, it's available in the foreign countries, you know. When you go to learn computer science, they bring a computer and they teach you the real computer science. If you've actually checked out our I think linked list class, you'll see students, I think in Harvard, we have a video there where Harvard students were being taught. You see how they teach them in class, and you now realize that software engineering, computer science students in Nigeria, we are still behind. In fact, we are not being taught, man. Not being taught. Anyways, um, we I will go further and we will. Where's this stuff? I'll go further and then we'll keep learning these things. Um, write the program that prints the number of arguments passed into it, right? So this time around is the Argc we want to work on. Last time we printed the Argv, you know. So this time around we want to print out Argc. I guess you guys can do this one because we just did Argv. Remember to use the unused. Anyways, let me just do it for you guys. I'm trying as much as possible to make this thing as easy as possible. So let's go right into it. vi1 dash ag dot c. Okay, that was the name. Yeah. So we are to include our include stdio dot h and also include name dot h. I'm still making that error. I saw it on the spot. Okay, this time around. Yeah. So what do we do? What do our main function do? So let's int main. We do remember the structure, right? Of collecting arguments. Arguments here int argc. Okay. And then the next one we want is a char to the pointer, you know, argv, right? And we want this to also be uh, a list. And not only do we want this to be a list, we want to still tell the computer that we are sure that we are not using this argument. So we want to say attributes unused, attributes. Okay, one more, right? Yes. So attributes unused. Okay, yeah. So that's it. It's supposed to actually have three at the end. Okay, that's three. Yeah. So that's it. We've told the computer here that we are not using the Argv. We So it doesn't throw an error. That's why we're adding this attribute unused at this side. Remember the first time it was here. Okay. So we are just avoiding C's problem. C is a very problematic language. So what do we want to do? They say we should print the number of uh, uh, arguments that was passed. Okay, we should print the number of arguments that was passed. So this time we need the placeholder to an integer, not the placeholder to and a new line, not the placeholder to a string. And then what do we put here? We put the Argc. All right, that's what we want. I remember something they said here. Print the followed by excluding the program name. Yeah. So if we want to print, we are counting. See, print the number of arguments on the screen, excluding the program name. So in essence, the program name, if the program name is the first argument, in essence, we want to remove one argument from it. So we want to do print argc minus one actually to remove the program name. Okay. So we are printing argc and we want to be subtracting one from it. Very important. Very, very important. If you don't do this, then you're wrong. And then we need to have a return statement. This is C programming. So we are returning something. Yeah, that's that for that. Let's go check what it is. GCC dash, no, not dash, GCC one dash arg.c, and we want to print something. I remember when I was teaching this stuff, uh, let's print it as what the number of args, right? N args. I remember when I started teaching this stuff at first, GCC alone was still giving people issues. Now it's like a normal thing. GCC is just something we just do to compile our code. It's not something to stress about. That's how every single concept in programming is. When you start doing it for the first time, it stresses you. It's not easy for the first time to start learning a concept in programming. But then when you keep doing it, it becomes a part of you and you just do it. So sometimes when you look at me and you feel like, oh, this guy knows like a whole lot, he's teaching us a whole lot. How does he have all of this stuff in his head? It's consistency. That's all it takes. You will get to the point where you write this code like me as well. And all you need is just to be consistent. That's all you need. If you keep following up with our programs, with all our classes and trainings and all that, at some point you would write this stuff just like I do. So I'm to hit the enter button and see if we'll have an error. Oh, no errors, so we are good. Number of args, nag. So yeah, so we have to run it, number of args, and let's add. Okay, first of all, let's print it without an additional argument. So it will print 0. Okay, and then we can now add this is my name. So how many arguments are here? 1, 2, 3, 4, 5 minus the first one, so 4. And that's what we are getting here. So we are correct. We now know how to count how many arguments are on the screen. And if your minds are working at this point, you should be seeing a vision of all the possibilities that you can do. You can see that you can now pass arguments that you can read into your computer. You can now read the arguments of your timeline into your script and now use them to form functions, to run functions, calculations, and all that, and return the outputs that you desire. You know, it's a very handy tool, Very, very handy tool. This is how we build the compiler. We build our compiler into a full-blown program. You know, this is where it starts. This is the starting point. I'm going to do a small program for you, and then we go further. In fact, today we use a very basic addition and subtraction kind of program, and then later, much later, would 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 you're actually going to build a simple shell program. So I don't have much to tell you. When you get there, you see what it is. Okay. Yeah. So that's that for that. We should go further. Clear our screen. What's the next question saying that we should do? I should not finish all of these things for you guys. Write a program that prints all the arguments passed to it. Okay, so this one is saying print all the arguments passed to it. And if you understand what that is, that means print everything in Argv, right? So we want to look through the list in Argv and we want to print all that there is. So requirements, print every argument including arg0. Okay, so arg0 is the first argument, which is the file name. So it says we should print everything including the file name. And then the next one says print one argument per line. In essence, after each argument, we should have a line break. Okay, and it's simple. It's we have an example here, but I think we can tackle this ourselves. Let me do this for you. It's just a loop that you should just do there. Any kind of loop that you like, you know. It won't stress. All right, let's go right into it. What's I think two dot args. Let's use two dot args. vi2 dash args dash arg dot c. Okay, should we add the s? Doesn't make it feel any better. Let me add the s. Two dash args. Yeah. Okay. First things first is include we include we are printing stuff to the screen. So I think I've said this too many times to not say it again. Our main.h file, including the prototypes that we created earlier. Okay. Yeah, so we jumped right into it, right into building our main function. Right. If you watch how I write this code, just to avoid syntax errors, I build the shell of the program first before I start writing stuff inside. Right. I don't just start writing int main and I finish writing what should the parameters before I start building the see. I don't start completing the parameters here before I put the parentheses at the end. I build the shell of a main function before I start adding anything inside it. So this is just to avoid syntax errors. That's how you should be writing. Okay. So yeah, so we are in Argc. Okay, and we are using, are we using that? Yeah, we are using it, and we are using Argv too. So this is a pointer, Argv, and yeah, so we are using the both of them this time. So what do we do? What do we do? What do we do? First thing that we want to do is let's int I. Let's create a let's create. We are using a loop. Okay, so let's initialize it. Let's say for I. Let's use a for loop. So we've created the shell of our for loop, and let's say for, remember how to do for loops. If I is equal to 0 and I is less than arg, I think that's what we should do. And I is less than argc, which is the total number of arguments. Yeah, what do we want to do? We want to say I plus plus. We want to increase I. So I is how we access each index of argv, you know, and then we just print it to the screen. That's going to be so easy for us to do. So we want to print f. Okay, we want to print f this. And what are we printing? We want to print the uh, uh, argv variables is what we want to print. Okay, placeholder first to s and backslash n, because the program says each time you print a new one, add a new line. So Argv, right? I Yeah, so that's that for that. And we tend to forget to return at the end of the program sometimes, but it's very bad to do that. Return zero. All C programs must have a return value, right? So yeah, that's that for that. Let's go check if this actually works. GCC 2-args and uh, what do we do? Let's print it into a file called print args, print underscore args, or let's just call it args. Let's just call it args, right? Any errors? No errors. So let's do that args, and let's add other variables that should be printed. What should we say? Okay, WinMingle community software engineering training program. Yeah, so that's what it is. It prints everything to the screen, all arguments to the screen. So now, just to let you know, since you're already having all of these arguments, your code could actually understand them and manipulate them, use them to do whatever you want them to do. Yeah, so we are almost getting there. Let me see you guys and talk to you guys before we go further. Okay, so if you guys can hear me, keep putting in comments so that I know that I'm being heard. I'm sure I'm being heard since nobody is complaining. Sure, I'm being heard. All right. We should go further then. What do I do? What do I do? I should go switch back. Okay. So the third one says write a program that multiplies two numbers. Yes. Write a program that multiplies two numbers. Okay. Now, let me explain. Okay, let's see the requirements first. Print the values, print the results followed by a new line. Print the results followed by a new line. That's the requirement after the multiplication is being done. If the program does not receive exactly two arguments that should be multiplied, print error and return one. Okay, so that's what it is. See it here. If it doesn't receive the arguments, print error, and then if it does, print the 2 times 3 is 6. Okay, so I'm going to do this for you, multiplication, and then the next one is uh, write a program that adds two positive numbers. Okay, I'm going to leave you to go try this out because I'm doing the much difficult one. I'm doing multiplication. Addition is easy, right? if if you've done multiplication, why would you not be able to do addition? Okay, so let's do the multiplication together. This is where I should build the a to I function. Now, um remember, first things first, we are writing C and we understand what data types are. We are passing values to the screen. Anything we pass to the screen, first of all, should be a string, not an integer. In essence, we need to know that first thing that should come to our minds is that, oh, we need to convert strings to integers since we want to do multiplication, right? And then how do we convert strings to integers? Let's come to a browser and ASCII. Let's ASCII table. Let's see what ASCII tables are saying about this stuff. Okay, let's just get a pretty basic one on the screen to look at it. Yeah, so this is like an ASCII table here, right? it holds the character values and the decimal values and hexadecimal values of each of the characters. Okay, so if you want to switch, from a character from a string to like an integer, if you want to switch or change a string to an integer, this is where we'll come and confirm what we are adding or deleting. It's very simple anyways. If you look for 0, where is it? Where is it? Yeah, character 0 is 48. You know, character 0 is 48, and uh, where is integer 0? I'm trying to. Okay, it has come up. Yeah, so this integer 0 here, 0, 1, 2, 3. So character 0 here is 48 at this point, and integer 0 here is oh, this at hexadecimal position. Yeah, decimal. Okay, yeah, that's the position actually of the 0. 0 is 0 here, 1, 2, 3 to 9, and 48 here is 0. Okay, don't worry. I should let's get there. Let's build the algorithm to the point where we now need to look at this stuff, so you would understand clearly what I'm thinking like in my head now. Because I feel like because I have not uh, gotten to the point, I've not written code, you might not understand what I'm thinking. Let's write it. Let's pen down something. So remember, our program is to take only 2 arguments. One condition that we need to build. We need to account for if it's a positive argument or a negative argument, and then we need to tell the computer, hey, this argument is positive or it's negative, and we'll do all of that in our a to I function. Okay, but first of all, I think we have to build like a main.c file that uses the a to I function to to print yes, that's how we'll do it. That's how we'll do it to make it easier. Let's head into program, and let's vi 3-mol.c. So we should start from building the main.c function. Like I told you, each time you see a program, jump to the main.c function and you would understand what the program is doing. So let's include, first of all, standard io.h, and let's include a main.c file, main.h actually file. Yeah, so first things first is I want us to build the main function first. So int main, yeah. So what are we passing? We are passing int argc here, and we are also passing char argv placer pointer argv give it a list. All right. So what we have to do here is int uh let's create variables here. We want int the 2 variables that we are multiplying. Okay, number 1, let's say num1 comma num2. Remember, you can declare numbers on the same line, and the last one we want to call is the result of the operation, of the multiplication operation. All right, and that's that. We've declared 3 variables, 3 integer variables, that we want to multiply. Like 2 will multiply num1 and num2, and the result will be saved in num3. That's the idea, right? So next thing that we want to do is we want to know if the number of arguments in the script, the number of arguments passed to the command line is less than 3, or if it's greater than 3. If it's less than 3, that's an error. If it's greater than 3, that's an error, right? Because the first argument should be the name of the file. The second argument should be the first number. The second argument should be the second number that it should multiply. So the name of the file that has the script, which is in this case the mul.c that we are running, and then the two arguments that it should be multiplying. Those are the three arguments that should be on your screen for this program to run effectively. So we want to find out if that was correct first. So what do? We run an if statement. In this if statement, remember, I always build the shell before I start typing. This is just my way of showing you how to avoid syntax errors. Okay. In this if statement, we want to say if argc is either less than or greater than 3. If it is less than 3, or remember when I taught you guys about operators, or if argc again is greater than 3. Either of these two that happens, we want to print that there is an error. Print f. Okay. Either of these two should throw an error. Okay. It says error. Okay. And we need to add a new line after saying that the input was an error. Okay. And then we need to exit. The program said we should return 1. Okay. So that's that for that if statement, right? That's that for that if statement. So this would break the function without, remember, we don't want to stress the computer. We don't want to use the reason why this has to be at the top of this file, this main.c function, is that we don't want to stress the program to start running and allocating memory to these variables, allocating memory to these variables when we are sure that there's nothing to multiply, or there are more values than 2. The program requires only 2 arguments, and we are sticking to that, only 2 arguments. In the long run, I'll teach you how to still use Argv for multiple arguments. Okay, and we are getting to the command line, and this is the basics of how you build a command line for yourself. Okay, and like I told you, in software engineering companies, many a times we don't care about graphical user interfaces. We know clearly what the commands do. We built the commands and we are using them from the terminal. It's faster. It's way faster than loading up a user interface. It's just to type and we get all the results we are looking for. We do everything. This is why I'm telling you that there's no cybersecurity learning without first being a software engineer. Because come on, when people start connecting to remote networks from shell programs, how do you that don't have software engineering knowledge, how do you keep track on what somebody is doing? How do you even know that somebody is doing something on your computer? There's like a whole lot. I think it's mediocrity to want to learn cybersecurity without being a software engineer. It's just, people just like how the name sounds. It sounds like you're a big boy, so you want to start learning it. It's funny. I see it, and they use it to entice people to just collect their money. They know that you cannot work anywhere in the world. They are very well aware of that you are inexperienced, you have no skill, but then they just want to take money from you. That's why they tell you you cannot be a software engineer and just come and learn cybersecurity. And work where? Please. You don't know anything. I can still manipulate your computers and all that, and you still not find out or know. You still not. You trust me, you need to be a software engineer first. That's the bottom line of what I'm saying. Anyways, so like I was saying, we don't want to allocate memory to num1 and num2 when the values are not correct. We expect 2 values after a file name, and that's why this function is very important. Very, very important. This function is really, really important because we 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 sorry, I need like a minute. I need a minute. Ah, sorry about that small problem. I had to. My neighbor called and they're like, "Hey, I should come remove my car," and I'm like, "I can't go drive out right now. You know, I'm in a meeting. They have to give me at least 30 minutes to finish this stuff." Ah, they are waiting, so we have to be fast with this stuff. Yeah. So without any further explanation, Argc and Argc, yeah, if it's less than or greater than 3, we should throw an error and let's move on. So the next thing, since this program is not ending, it's not returning at this point, it means we are correct. We have two variables. We should now do the addition. The addition is simple. We want to use num1 and say num1 is equal to the a to I function that we'll build, underscore a to I function that we are going to build, and we want to pass into it the argument variable 1 at position 1. Yeah, we want to pass into it argv at position 1. Remember, position 0 is the name of the file. Position 1 is the number 1 variable. Now we are passing this, so number 1 now becomes the first number, and then num2 is equal to a to I and underscore, oh sorry, this is argv2, argv2, right? This is argv2, and what do? We want to say result is equal to num1 num1 multiplied by num2, right? So that's all that there is to this stuff. So what are we returning? We want to return, or let's print, use a printf. Let's do a printf, and uh guess I should give these people my car key so they drive out. uh I'm so distracted. I feel like um I'm the reason somebody is not able to go to where they want to go to. So we want to print an integer here, not a string, and is the result we are printing, right? So yeah, finally we return something, return 0. Yeah, so let's see. No, we can't see if it's working. It can't work right now. uh we have to build the a to I function, via to I. uh let me I'll have to end the stream and come back again, because it's something. I don't have anybody around that can help me right now. So I'll be back in a few minutes. Take the time to practice what we've done so far, and we will continue. I'll be back. I just need to solve a problem. It's very important. All right. I'm really behind.